In this video we are going to see how to control a device connected to NodeMCU using Adafruit IO cloud platform. So in the Adafruit IO platform we will be creating a small button. By pressing on that button we will be able to control an LED present on board the NodeMCU. So when you are pressing the button, onboard LED will be on. When you are releasing the or when you are pressing it again, the onboard LED will be off. That is what we are going to do using an Adafruit IO cloud platform. So first of all we need to search for Adafruit IO. Then you will be getting the Adafruit IO web page, that is io.adafruit.com. You can click on this welcome to Adafruit IO platform. So if you don't have an account in Adafruit IO, you need to create an account. So since I am having the account, I am clicking on sign in. Then I am giving my username and password. So once it is signed in, you will be getting a screen like this. Since I have created few feeds, few dashboards, etc., it is showing like this. If you are a new user, you will be getting all these things as 0, that is devices 0, group 0, feed 0, dashboard 0, etc. Like that you will be getting. So the first step what you need to do in this Adafruit cloud platform is you need to create a feed. Feed is something like a variable where you are going to store or read the data from. So in my case, when I am pressing the button, I will write 1 to this feed. When I am pressing the button again or when I am releasing that button, I will write 0 to this feed. So for time being, I am giving a feed with the name LED. So for that I can click on feeds. In the top menu bar you can click on feeds. You can see so many feeds are created here. So yesterday I have created a field known as LED. So for time being I am deleting it. So I can click on that LED and I am clicking on delete feed. Delete feed. If you are a new user, you won't be having anything. You can directly create the new feed. So here you can see two buttons are there, new feed and new group. We are going to create a new feed. So click on new feed and I am going to give the name of the feed as LED. Then I am clicking on create. So you can see that in the bottom one LED feed is created. The feed name is LED. Feed key is also LED. It has been created. Next step I need to create is I need to create a dashboard, because it is in the dashboard where you are going to place the button or say gauge or graph or table, etc. Whatever widgets you need to have in your application, you are supposed to create a dashboard for that. In that dashboard we are adding all these widgets. So in the top menu bar click on dashboard. Again, since I am using it for some time, many dashboards are there, and since it is a free account, we can create only maximum 5 dashboards. So now already 5 dashboards are there. So for time being I am going to delete one dashboard. So I am going to delete this ESP_div_control. I am going to delete it. If you are a new user, you will not see any of the dashboard here. You can directly click on new dashboard. So I am clicking on new dashboard. I am giving a name for the dashboard, ESP_device_control. ESP device control. I am giving a name. Then I am clicking on create. So you can see that in the first itself your ESP device control dashboard is created. Now you can click on this dashboard. Then you can see that this dashboard don't have anything now. It is a plain dashboard. Now I am going to add a simple button into this dashboard. A simple button I am going to add. That button is nothing but a widget. So for that you can click on this settings button, that is nothing but dashboard edit controls. Click on that. Then click on create new block. Click on create new block. Inside this you can see toggle button is there, momentary button is there, slider is there, gauge is there, table is there, then map is there, keypad is there. So many things are there. For time being I am selecting only toggle button. So I am clicking on that. So once that toggle button has been clicked, you need to select which feed you are going to control using that button. In my case I am going to control the LED feed using the button. So I am selecting the LED feed. Then scroll down. Once the LED feed is selected for the toggle button, click on next. So when you are clicking on the next, it will ask for the title what you need to give for this button. So for time being I am giving ESP device control itself. Then button on text. When the button is on, what should be displayed here? By default it is on. When the button is off, what should be displayed here? That is given here as button off text, that is off. Then button on value. When you are clicking on the button or when the button is on, what value should be sent to the feed? So in my case, when I am pressing on, I should send a value 1 to the feed. Which feed? LED feed. Similarly, I need to give the button off value also. When the button is off, what value should be sent to the feed? So I am clicking on this and I am giving 0. So when I am switching on the button, I will be sending 1 to the LED feed. When I am pressing off the button, I will be sending 0 to the feed, LED feed. And using the Arduino program, you are going to read from the feed, and if the feed value is 1, our LED will be on. If the feed value is 0, our LED will be off. That is what you are going to see. So now the settings for the button is over. Then you can click create block. So now you can see that you are having a dashboard with a name ESP device control. Inside that you are having a button and the title given to is ESP device control. When you are clicking on once, the button will be on. When you are clicking on once again, it will be off. So only this much you need to do in the Adafruit cloud. So next we need to go through the program or the NodeMCU code where you are reading the data from this LED feed, and based on the data or based on the feed, if the feed value is 1, our onboard LED should be on. If the feed value is 0, our onboard LED should be off. That is what you are going to see. Now we will go through the NodeMCU program for controlling the LED using Adafruit IO cloud platform. So initially we are including few header files. One is for ESP8266 Wi-Fi, another one is for Adafruit _ MQTT, another one is for Adafruit _ MQTT _ client, then finally Adafruit IO Wi-Fi libraries. These libraries we are adding to the program. So if this Adafruit MQTT is not installed, you need to install it through this library or through the library manager. Now I have already installed it, so there is no problem. So once you can, whenever you are getting a program like this, you can run this program. If it is not running properly, it will show you need to install that particular library. Then you can go to the library manager and install the corresponding library. Then we are defining Wi-Fi SSID, Wi-Fi password, Adafruit IO username and Adafruit IO key using these 4 statements. So hash define Wi-Fi SSID space, between this double quotes you need to give the SSID of your Wi-Fi hotspot. In the next statement, between this 2 quotes you need to give the password of the Wi-Fi hotspot. Then here you need to give the username of the Adafruit IO cloud, and here you need to give the Adafruit IO cloud key. So this username and key differentiates between the feeds of each and every person. So if I need to write the data into my feed, then the username allotted to me should be used here. Similarly, the key allotted to me should be used here or should be given here. So how will I find that? You can go to Adafruit Cloud. In the top you can see one key like symbol. It is written API key. You can click on that. When you are clicking on that, you will get the username as well as the key. Username you will be getting, active key also you will be getting. So this is how we are getting the username and active key for IO Cloud. So before compiling the code, you need to fill all these things. You need to enter the SSID of your hotspot, password of your hotspot, username of your Adafruit IO and Adafruit IO key. All these things should be filled in. It should not be given as blanks like this. In the next step, we are creating a class object for a class known as Wi-Fi client. Then we are creating a particular instance for Adafruit IO client. For creating that instance, you should use Adafruit IO Wi-Fi space IO bracket whatever you have used here, that is a username, key, SSID and password. So by using this function or this method, we are creating an instance of the Adafruit IO client. Then similarly we need to create an instance for the Adafruit IO feed. How will I do that? Adafruit IO underscore feed space star LED. This is my feed name, right? Star shows that it is a pointer. So star LED equal to IO dot feed in bracket whatever name you have given in the Adafruit IO, that same feed name you should give here. IO dot feed in brackets whatever feed you have used. I have used the feed as LED, so that same LED feed I should give here. Then I am initializing the LED pin as 2 because 2 is the GPIO where my onboard LED is connected to. Then inside the setup function, you are initializing the serial port with 115200 baud rate. You are configuring the LED pin as output. You are initializing the LED to low. So here LED low means the onboard LED will be on, because in the ESP8266 the anode of the LED is connected to 3.3 volt and cathode is connected to a GPIO2. So in GPIO2, when you are writing low or 0, LED will be on. You need to keep in mind. Normally when you are writing low, LED will be off, but here the connection is reverse. The anode of LED is connected to the VCC or 3.3 and cathode is connected to GPIO2. So when you are writing 0 to LED pin, LED will be actually on. Then you are printing a message connecting to Adafruit IO in the serial monitor. Then you are connecting to the Adafruit IO using function known as IO.connect. What is this IO? IO is the Adafruit IO client instance what we have created in this step, right? So using that Adafruit IO client instance, we are connecting it, IO.connect function. Then after that we are checking whether the connection is successful or not. So for that we need to use IO.status function. IO.status function will return a value AIO connected underscore connected if the connection is established between the NodeMCU and the Adafruit cloud. So here I am checking whether it is less than this value. It is, if IO status is less than this value means it is not connected. It will be connected only when these two are equal. So when it is less than means it is not connected. So it will print a dot. It will wait for 500 milliseconds. Again it will keep on checking the status. So this function will be, this while loop will be executed until the connection has been successful. When the connection is successful, this statement will be false and the while loop will be exited. Then it will print the status text, whether it is connected or whatever it is, that will be printed. After that we are setting up a message handler for the feed. My feed name is LED. I have declared it as Adafruit IO feed star LED. So this is my feed variable or pointer to the feed. So LED, this symbol is used because we are using LED as a pointer. So LED on message bracket handle message. What does it mean? Whenever a data is received in the LED or whenever a message is received in the feed LED, this function will be executed. Whenever a new feed value, that means when you are pressing the button in Adafruit, you are sending 1 or 0 to the LED feed. Whenever LED is getting a new feed, this function will be executed. Which function? Handle message. That is why it is given as LED on message bracket handle message. So whenever there is a new message coming, it will execute this function. So till here it was setup function. Then inside the loop function only one function is there, IO.run. So this is required to keep the connection between Adafruit IO and the NodeMCU live always. That is why it is given IO.run inside the loop function. Then we will see the description for the message handler, because whenever new feed is received on the LED, handle message function will be executed, or this is the message handler for the on message on LED. So we will see that. So this is a function for that. So handle message bracket Adafruit data star data. So this data is of type Adafruit data. It is also a pointer. So once the data or the feed is received in LED, the data is sent to this function, right, and it will print the message as received. Then it will read the data. How it will read the data? Data followed by value. So data value gives the value that is stored in the data. So it will print it in the serial monitor. The data will be 1 or 0 based on the button press. Then what should I do? I am converting this data to pin level. Pin level means pin level can be either high or low. When I am reading the data as value, I will be getting 1 or 0. I am going to convert it into high or low. Then after converting it, for converting that I am using to pin level. Data to pin level will convert the data, numerical data, to high or low. So if it is equal to high, what should I do? You can understand that the feed value which is written onto the LED feed is 1. So I need to make the LED on. For making LED on, I am using digital write LED pin comma high. Similarly, if the value or the feed value which is sent to the LED is 0, then this condition will be false. When 0 is converted to pin level, it will be represented as low. So the data is not equal to high. So we need to make the LED off. How will I make the LED off? Digital write LED pin comma low. So in this function, the data received in the LED feed will be read and it will be checked whether it is high or low. If it is high, corresponding onboard LED on the NodeMCU will be on. If it is low, onboard LED will be off. So now we can upload this program. So before uploading, you need to keep one thing in mind. You need to fill the SSID, the password, Adafruit IO username and Adafruit IO key. Now we can upload the program. Now the uploading is going on. So the program has been successfully uploaded. Now we can click on the serial monitor and you need to change the baud rate to 115200. Need to change the baud rate to 115200. In order to restart the controller, I am pressing the reset key in the NodeMCU again. So it will try to connect to the Adafruit Cloud IO. Once it is connected, it will show connection successful. So now you can see Adafruit IO connected. Message is shown. That means your NodeMCU is connected to the Adafruit Cloud. Now you can take the Adafruit IO, and you can see that when you are pressing on the on button in the Adafruit Cloud, onboard LED on USB 8266 will be on. When you are again pressing on the button, the onboard LED on the ESP 8266 will be off. But since I have told that the cathode of the LED is connected to GPIO2, when you are pressing the on button here, the LED onboard the NodeMCU will be actually off. When you are pressing the button to off state, the LED will be on actually, because when you are pressing off, you are writing a value 0. When 0 is sent to the NodeMCU LED will be on, and when you are pressing on the on button, you are sending 1 to the NodeMCU, and when 1 is sent to the NodeMCU, the onboard LED will be off, because cathode is connected to a GPIO2. So 1 means 1, if we are giving to cathode, it will be off. So this is how you are controlling a remote device using Adafruit and NodeMCU. Now we will see the working of the project. So when I am clicking on the button in the Adafruit IO, now you can see that the button is on. When I am clicking on it, it will be changed to off. So when the Adafruit button is off, LED on the NodeMCU is on. Why when button is off, LED is on? Because when you are pressing the button to off state, we are writing a value 0 to LED feed of the Adafruit IO. So when I am writing 0 to LED feed, that 0 value will be sent to GPIO2 of NodeMCU. In GPIO2 of NodeMCU, the cathode of the onboard LED is connected. When the cathode is written with a value 0, LED will be on. That is why when you are switching off the button, the LED onboard is on. Now I am going to switch on the button. Now I have switched on the button. Now you can see that LED onboard NodeMCU is off. Why? Because when I am switching on the button, you are writing a value 1 to LED feed of Adafruit. When you are writing 1 to LED feed of Adafruit, similarly I have told before, the cathode of LED is connected to GPIO2. So when I am writing 1, the LED onboard will be switched off, because in cathode you are writing 1. So that is how when you are switching off the button, LED is on, and when you are switching on the button, LED is off in the NodeMCU using Adafruit. So this is how you are able to control NodeMCU using Adafruit.